Hello friend, in today's video we will learn how we can design and develop a face mask detection project by using Raspberry Pi with the help of machine learning algorithm. So in this video we will learn how to do the hardware connection, how to do the programming part, how to do the machine learning algorithm, how we can train our faces to identify the mask detected or mask not detected, and after the mask not detected there will be the buzzer, and there will be the light also, gate will be open and gate will be closed if the face mask is detected. So in this video we will learn complete thing, so I request you please watch this complete video so that you will get idea about each and everything about this project. So in this video we will cover first what is the final output of this project so that you will get idea about how this project will be work. And then later part we will see how we can connect all different types of hardware like L293D motor driver IC, buzzer, LED, camera and temperature sensor with Raspberry Pi. And then we will see how we can design and develop a program which detect the face with the mask. Also we will design our own algorithm so that it will detect the face with the mask. So I request you please watch this complete video so that you will get idea about each and everything about this project. You do not need to pay any single rupees for this project. This project completely free. You can download the complete project from the Google Drive link given in the description. So I request you please watch this complete video so that you will get idea about each and everything. So first I will tell you what will be the flow of this project. As you can see on the screen, the hardware part of this project. You can see on the screen there is Raspberry Pi, then there is a LCD, then there is a buzzer, then LED, and there is motor driver IC with motor is connected. So flow is like when someone come in front of the camera, then our camera will detect the person wear the mask or not. If the person do not wear the mask, then gate will be not open. At the same time the buzzer will turn on and red LED will turn on. The second part is if the person wear the mask, it will come again in front of camera, then it will check the body temperature of the person. If the body temperature of person is greater than 32 degrees Celsius, for this I will use the LM35 sensor for the demonstration purpose. So if the temperature is greater than 32 degrees Celsius, then again the buzzer will turn on and red LED will glow. Again the third part is, let's say if the again another person come in front of the camera, then it will detect the person temperature, and if the temperature is below normal below than the threshold level, then it will check the mask. Then camera will check there is a mask or not. If the mask is where that person, then automatically green light will turn on, then gate will be open for the some time and gate will be closed. So this is the complete idea behind this project. Also we can see the status of scan the spaces, different types of setups like get open, get closed on the LCD of the Raspberry Pi. So this is the idea behind this project. Now we will see the practical demonstration of this project. So when you start your project, if no person sit in front of camera, so you can see on the LCD scan your face message is printed, so it will waiting for the face. Also you can see gate also close and both LED are not glow, and the buzzer also turn off. So next part is I will come in front of camera and I don't have the mask. Now we will see if the person do not wear the mask and come in front of the camera. So you can observe the red LED, also buzzer operation. So I will come in front of camera without the mask. So now I have wear the mask, so you can see on the LCD screen again the mask is detected message print on the LCD and green LED turn on and buzzer stop ringing. And also on the LCD you can see get open message also there. I can show you that part also. So you can see get open message also there, green LED also turn on and buzzer stop ringing. So this camera is scanning my faces continuously. Now I have removed my mask, so you can see this camera is scanning my face again, red LED turn on and buzzer start ringing. Also you can see on Raspberry Pi screen no mask detected, mesh also present. So this is the complete idea behind this project. So before start the hardware connection part, I request you please subscribe my channel. You can see currently I have 1231 subscribers, is more than 1000, but to verify my channel on the YouTube I require 4000 watch hour, and currently I have approximate 3000 watch hour. So please watch my each and every video from my playlist. Just go to my playlist. This is my playlist, and go to my playlist. You can see there are many videos on Raspberry Pi, Arduino, webinar, and in Raspberry Pi more than 45 videos there. And if you want to learn the Raspberry Pi from me in the free, you can subscribe my channel. You can take this advantage, and all these video are very unique. You will not find this video on the YouTube channel. So please subscribe my channel. Please watch my complete video. Thank you for support. Okay, now first we will connect the LCD module with Raspberry Pi. As you can see at here, I have LCD module separately and Raspberry Pi separately. So on LCD module you can see this is designed by me, and also the you can see it is completely designed on, now you can see it is completely designed on the 0 PCB. So how I designed this, you can see on the screen the schematic diagram of this LCD module. So on real time we have this only we get this. So on real time when you buy on the Amazon, you only get this LCD module, and this LCD module has this 16 number or 50 number pins. So with this 16 and 50 number pin, you have to how to connect that one with Raspberry Pi. For that you require this 0 PCB module. So how I design this 0 PCB module? By using the circuit diagram. So I will share the circuit diagram on screen. You can see on the screen whatever the pin, output pin is connected to input side of controller. So that input side of controller pin is nothing but our floating pin, and with that floating pin we will connect our LCD module with any other controller. So with the help of this circuit, I have designed this circuit. So when I plug this, so whenever I design this circuit, I need to plug this one LCD module on this one. Okay, now with this you can see at this side we have common VCC, at this side we have common ground. Then at this point you can see there is a input pin of this LCD module. So first pin is RS pin, then enable, then D7, D6, D5 and D4. So these are the output pins of this LCD. So we will connect only this pin with Raspberry Pi, the VCC and ground pin also with Raspberry Pi. So I hope with the 0 PCB or breadboard PCB you can able to create this circuit with the help of circuit diagram. I have shown on the I already shown on the screen. So please create this circuit diagram by your own, by soldering the PCB like this one, or by using the by using the breadboard also. Okay, now once you get this once you create this circuit on the 0 PCB, now we will connect this pin one by one with Raspberry Pi. So first point we will connect the RS pin to pin number 7. So for that we require the female to female connector. So I will connect the RS pin to the pin number 7. You can focus, this first pin is RS pin. Then I have connect this RS pin to pin number 7 of Raspberry Pi. So before starting the next part, I need to pay your attention here. You can see on Raspberry Pi, I by myself only created this page and paste this page on the Raspberry Pi pin, so that I can easily identify the pin number of Raspberry Pi. So even number pin come at this side and odd number pin come at this side, but with this page number I can easily identify the pin number of Raspberry Pi. So I hope you also do the same at your side, so that you can easily identify the pin number with Raspberry Pi. So first pin is this one, then second, then third, then 4, 5, 6. So even number at this side and even number at this side and odd number at that side only. Okay, once you connect the RS pin, next pin is enable pin. So I will connect enable pin to pin number 11 of Raspberry Pi. So take this enable pin and I will connect this enable pin to pin number 11. Now we will connect the D4 pin from this PCB to Raspberry Pi 12 number pin. So connect D4 pin with Raspberry Pi 12 number pin. Okay, after that connect the D5 pin to Raspberry Pi 30 number pin. So D5 pin from Raspberry Pi connected to 13 number pin. After that D4, D5, D6 pin should be connected to Raspberry Pi 50 number pin. So D6 of LCD should be connected to Raspberry Pi 15 number. Then after that D7 pin should be connected to Raspberry Pi 16 number pin. So D7 should be connected to Raspberry Pi 16 number. So in this way we have completed the connection of LCD module. With Raspberry Pi. Now we will give the common ground and common VCC to Raspberry Pi. So this side act as a common ground and this side act as a common VCC. So ground pin of Raspberry Pi is nothing but the 6 number pin. So I will connect ground pin to Raspberry Pi 6 number pin. Then VCC pin of this LCD should be connected to 2 number pin of Raspberry Pi. So VCC pin of this LCD should be connected to 2 number pin of Raspberry Pi. So in this way we have completed the circuit part of LCD with Raspberry Pi. So once we connect the LCD part with our Raspberry Pi, next point is I have to show this circuit to you. So what is this circuit? So you can see on this circuit it is a 0 PCB circuit having female buck strip at one side. So 2 female buck strip here, and at the opposite side I have shorted the 1 female buck strip completely here and 2nd female buck strip completely here. So what is important of this pin? So basically Raspberry Pi having only 2 VCC pin and 1 ground pin, or let's say 1 or 2 ground pin, but in our circuit we have many models and we require the many VCC and ground pin. So for that I have taken the common VCC pin at this point and common ground pin at this point. So whenever I want the VCC and ground, I directly taken from this 2 pin. So you can also make this circuit at your end so that it can be work as a common VCC and common ground purpose. So I will place here. Now you can see Raspberry Pi's 2nd number pin, for 2nd and 4th number pin act as a VCC. So I have connected the 4th number pin as one point here. So this pin act as a VCC pin. Now Raspberry Pi 6 number pin act as a ground pin. So I will take the Raspberry Pi 6 number pin from here and this 6 pin number pin act as a ground pin. So I have connected here. So whenever I require VCC ground, I can directly take from this 2 pin. So you can also make this type of circuit at your end. Now the next point is motor driver IC. So if you want to connect the motor driver IC, you can see on the motor driver IC there are output pin and the input pin. So input pin I can read for you. So input pin is A1, A2, then enable, then VCC and then ground. So A1, A2 pin is go to the Raspberry Pi pin, then enable pin is go to the VCC pin, then again VCC pin should be go to the VCC pin and ground pin should be connected to ground. So one by one we will connect that pin to Raspberry Pi. Now at the output side there are again the 6 pin. So I will show you what is important on this 6 pin. So with first 2 pin and last 2 pin is basically used for the motor, and middle 2 pin is basically used for the power supply of this motor. But this motor require only 5 volt power supply, so we do not require the external power supply. So we will not use the middle 2 pin and we will use only first 2 pin. So first 2 pin act as a input pin for this motor. So whatever the motor pin we have connected directly at this point. So you should also connect this motor pin 2 pin at this output point of L293D IC. Now connect the iron 1 pin of motor driver IC to pin number 31 of Raspberry Pi. So take the iron 1 pin, 1 female to female, 1 female to male connector, 1 number pin, input pin of motor driver IC. This pin should be connected to female pin you require, and 1 female to female pin here, and the second part of female to female pin should be connected to 31 number pin of Raspberry Pi. So this is the 31 number pin of Raspberry Pi I have connected here. Now the second input pin of motor driver IC should be connected to 32 number pin of Raspberry Pi. So connect this one to 32 number of pin of Raspberry Pi. Okay, now the next part is enable pin. So enable pin should be connected to VCC pin of our circuit. So again take this pin, enable pin, and enable should be connected to common VCC point here. Now the next part is VCC pin of motor driver IC should be connected to again common VCC pin. So again take this pin, VCC pin of motor driver IC should be connected to common VCC pin. Now the last pin of motor driver IC should be connected to ground pin, common ground pin. So take the last pin again here and it should be connected to common ground pin. So in this way we have completed the circuit part of motor driver IC. Now the LED module, you can see this is my LED module, and in this LED module I have connected the LED, and one point of LED is connected to resistor, and another point of resistor is go to the VCC supply or ground supply, and again second point of LED module should be connected to this buck strip. So you can see at the output side I have created that circuit. So in simple way, one point LED having 2 point, one point is connected to resistor and second point is directly connected to Raspberry Pi. So this is the LED module, and this point of LED module is work as a ground pin. So I have taken this point here and this as a ground because connected to common ground point. Now the green LED module pin, this pin should be connected to Raspberry Pi 29 number pin. So again take the second pin and should be connected to Raspberry Pi 29 number pin. Okay, now the same point, the LED again a red LED having 2 points, one VCC, one ground. One point should be connected to resistor, and from that resistor we are giving the voltage supply or connected to Raspberry Pi. Another point again go to the voltage supply or Raspberry Pi. Now this point of LED, it is second point, is work as a ground pin. So I will take this pin and connect it to common ground again. Then this point of LED should be connected to Raspberry Pi 33 number. So I will connect this pin to Raspberry Pi 33 number. So in this way we have completed the LED part of our circuit. Now next part is buzzer module. So you can see this is my buzzer module, and buzzer having the 2 pin, only the positive and negative. Negative pin should be connected to ground and positive pin should be connected to Raspberry Pi pin, that is the 36 number. So only take one, whatever the big part is positive pin and small part is negative pin. So first connect the small part of buzzer to negative side, that is the ground side, and ground we have common ground here. So I will connect this one to common ground, and the positive side of buzzer should be connected to 36 number of pin of Raspberry Pi. So connect the positive side of buzzer to 36 number pin of Raspberry Pi. Now to connect the camera, I have USB camera, this one. You can order this camera from the Amazon or from the Flipkart, or you can also order the camera which is Raspberry Pi camera. At my side I will use the USB. So you have to just put this camera at USB side only, plug this camera to USB side only, and that's it. So one part we miss, actually we have to give the common, which is common ground, to LCD pin. So this pin act as a ground pin, so I will take the ground pin of LCD to common ground pin again here. And the next part is common VCC pin. So this point of LCD should be connected to VCC pin. So connect this pin to VCC pin again here, common VCC pin. Okay, so in this way we have completed all the circuit. Only a temperature circuit explanation is remaining, but I intentionally I have not covered the temperature circuit in this video, because I have already covered the how to connect the temperature sensor with Raspberry Pi in my this video. You can see on my playlist temperature sensor with Raspberry Pi this video. So I will give the video link in the description. So all the connection is the same. You have to perform after this connection. You have to perform that connection one by one with the help of this video temperature sensor with Raspberry Pi. I will provide the link in the description. So in this, after that your circuit will be completed and your project 100% will be work. Now we will see the important program setup for this project. So before start the programming, make sure that you have to install some library to work this project. So first go to the Raspberry Pi terminal. So in this terminal you have to type one command. First command is sudo apt get update. Then after that once you enter this, press enter, and then update will bar. I have already updated my project, so I will not again update this. Then after that again enter the second command sudo apt get upgrade and press enter. So once you press enter, the Raspberry Pi start upgrading his operating system. After that second important thing is you need CV2 library. So if you don't have the CV2 library, in case if you don't have the CV2 library, then you need to install Pi3 install CV2, but it is only whenever you try to run the project, and if you get the error CV2 library does not install in your Raspberry Pi, then and then only you need to install the CV2 library, otherwise you will not require. So before install the CV2 library, first check CV2 install in your Raspberry Pi or not. Just type this command, just open this program collect phase data.py and run this project. So once you run this project, if you don't find any error like here only CV2 library not found, then and then only you can type this Pi3 install CV2. Okay, and next and very important library you need to install this one, Pi3 install this. Type this command completely, copy this, and again go to the Raspberry Pi terminal and right place and paste here and press enter. So once you press enter, SIKit learn library will be installed in your Raspberry Pi, and this library is very important to work face recognition system in your Raspberry Pi. So you have to install this library, OpenCV library, if you don't find the OpenCV library, and all this thing. Okay, so with this you can able to download and install the library that require in this project. Now the next part is you have to create one folder in your desktop or anywhere where you want to run your project. So just right click there and create a new folder. So once you create a new folder, give the project name whatever you want, and once you give the name, you can see this folder you will find. So after this folder you have to download these three files from my Google Drive link. This one, correct phase data, final mass detection with hardware, and Harscade front phase default.xml file. So these three files you have to download from my Google Drive link. It is very important. So we will see importance of each and every file. So first you have to open this file, correct phase data. So once you open this file, what important changes you have to done at your side is just focus here. So at line number 10 you can see there is a path of this XML file. So how to change that path? First erase this path at your end, then go to your downloaded folder on desktop or wherever you have saved that file, Harscade default, right click on this file and copy the path. So once you copy the path, go to again this Sony browser and paste here that path, and after that save. So this is the basic setting you have to do before run this correct phase data. Now I will tell you what is the importance of this correct phase data. So basically this correct phase data file, it is used to create our library. It is used to create our database for with mask or without mask photo. So to create that database, we will use this cascade algorithm, that is front face default.xml algorithm. So is her cascade algorithm. What is this algorithm will do? It will capture whatever your faces from your video, and after that it will capture that image and it will store into one .npy file. So we will design two files. One file will we have the with face, and another file will have the without face. So first we will do with without face mask. So we have to do, just go to the 40 number line and npy.save. Here you can type without mask.npy. So this is the my file where I want to store the data when I do not wear the mask. So now we will see importance of each and every line, then we will collect the data. So first line is import CV2. Basically this is library where we can capture the image, we can do the some operation on image, so that we will use this line. Import numpy as NAMP. Basically again this is the next line where we whatever the data we have captured, that we have to store into our numpy file. So for that we will use this library. Next is to start the camera. So whenever you want to start the camera of Raspberry Pi, you require this line, capture cv2.video capture 0. So here 0 means the default camera when I have connected my camera to USB, so that I have given here 0. If you have connected your camera to Raspberry Pi or anything, you can try with 1 or 0 also. If 0 works at your end, well and good. Okay, so 0 not work in your end, then you can replace with 1, but by default is 0, which taking the USB camera. If you have the USB camera, then it should be the 0. So it will creating one object capture, and with this object we can access the camera of Raspberry Pi. Now next file is whatever the XML file, that is default XML file, we have to load into the Raspberry Pi. So how to load that XML file? By using this line, cv2 cascade classifier and then file path, and then we will taken this one object to access that file. Now next is data. So it is a basically array which we store our with face or without face data. So for that we will use this variable. Now while one, after whatever the content with the inside while one, that is execute for infinite number of times. So how to open the camera? So to open the camera you require this line, capture.read. So once this happen, the camera will be open and start clicking the image. So if the camera is okay or it is faulty, then it will, if it's okay then flag having 0 value, and if it's okay, if it's faulty then flag having 0 value, and if it's okay then flag having 1 value. And image, basically whatever the image captured by the camera, store into this image variable. Then after that her data dot detect multiscale. It is a function where exactly the square boundary within your face will be created, and with that face get stored into this faces variable. After that so whatever the faces structure, that boundary part is there, it will having x, y, w, h parameters. So it is nothing but the width, height and the pixel value. So if there is this parameter inside this faces variable, then after that we have to draw the rectangle over that faces. So to draw the rectangle, this is the function cv2.rectangle. Whatever the image we are capturing from this capture.read function, we are passing that image, then xy coordinate, then width and height coordinate, then 25, 0, 25 to 55. Basically it is the color value of that square box. So if you want to change the color value of that square box, you can change with any number, and 2 is the thickness of that box. And after that we have to slice that image. So whatever the square box is present, we have to slice only that square box. So to slice that only square box, the first square box, this line will be used. Then after that whatever the square box, let's say my face having the some another dimension and other member having some another direction. So to make all the faces to equal direction, we will use this line cv2.resize. Whatever the faces we have sliced, then 50-50. So it's 50 width and height and width, whatever the dimension. Then it is stored into again one faces variable. Then after print length, so let's say one face is detected, then this data having the 1 value here. So this data having the one value, then after that we are taking less than the 100 faces, one in one database. So here what we are doing, less than 100, the less than 100 means we are taking the without face mask image for 100 times. So if you want more data, you can give here number more than 100, like 200, 300, whatever you want. For my project I have taken less than 100, so 100 image is sufficient for me. And if it's less than 100, then what happen, whatever the image captured by our camera without mask, that image store into this data array. So whatever the image, indirectly it's nothing but the array, pixel of array. So that pixel of array we need to store into this data variable. How to store this data dot append function, and whatever the face we have captured, that is pixel, we store into this array. So one image having that whatever the pixel gets stored into this data variable. Then cv2 dot show output image. So basically whatever the camera image captured by whatever the image captured by that camera, it should be displayed on the screen also on this Raspberry Pi. To display that screen, cv2.imshow function will be used. Then if cv2.weight2 is equal to 7, so let's say if you want to turn off the capturing part within the 50 image, so for that we use escape button. So escape, this 27 is nothing but the ASCII value of escape. So once you press the escape button, then whatever the data you have copied into this data variable, that copy into without mask npy. So see, this numpy is nothing but our data, we can say the complete data file which having the without face mask images. So this file we will use later to identify with mask or without face mask in our machine learning algorithm. So in this way we capture without face mask, we collect the without face mask images one by one. So I can show you how this happens. So I hope you understand the importance of each and every line. So let's say if I run this code, click on this run button, and if there is no error, cv2 error, numpy error, then you can see 0 value first, then output image will open and it start capturing my whatever the image present currently on the screen. So you can see the number also increases 20, 21. So it will go till 100 times. So you have to wait till 100 times. I already done my face. So now you can see with inside your folder, once you take the without face mask, this without mask .npy file will be created and it is having your image database. Now we have to do the same operation but with mask. So change the file name at line number 40 with mask, save this file and wear the mask again. So once you wear the mask, again run the click on this run button. So you can see again it will start taking whatever the with face mask images one by one till 100 time. You can see count increases 17, 18, 19. So wait till it's 100 happen, and once the 100 happen, press escape button. Now you can see once the 100 happen and you press the escape button, you can see with mask.npy file also created. Now once you collect all the data files, you have to open the second program. The second program is this one, final mask detection with hardware. So double click on this program. So once you double click on this program, you can see this program will open here. So what is this program will do? So in this program, first we'll train our model, machine learning model, which can identify the with face or without face data, and based on that it will give 0 or 1 output. So we will see the coding of each and every line now. So first line is import time. So basically if you want to create some delay in your code, you require this library. Then import raspberry pi.gpio. Basically whenever you want to access any GPIO pin from Raspberry Pi for any hardware, then you require this library. Then import OS, if there is OS functionality, then you will require this line. Then it is not required parse, and this one it is extra line added by me, so I will delete this one. Next part is import SPI dev. So basically Raspberry Pi do not have the inbuilt ADC. So whatever your temperature sensor send the data to ADC, that need to be converted into analog to digital form, and that data should be converted by the external ADC IC. And to access that ADC IC, you require the SPI communication, and for that you require this library. Then set mode GPIO board. We are using the Raspberry Pi as complete board, so that we define here as a complete board. Then GPIO.set warning to the false. So whenever you run the code, Raspberry Pi gives you warning that whatever the GPIO pin you have used is already used before. So to avoid that warning, you should use this line. Then CV2 is basically image processing part. NumPy also I have already told you. And last three line is basically used for the machine learning algorithm. So we will see importance of that package later. So next line is we have to define all the our GPIO pins, whatever we use in our project. So first, all pins are for LCD. So in hardware part, as already told you, the RS pin is connected to 7 number, then enable pin connected to 11, then D4 is 12, then D5 is 13, then D6 is 15, and D7 is 16. So all this pin whatever I have used in hardware, that I define here. Then same for the green LED, then DC motor, and then buzzer. So whatever the pin I have used for that hardware, I define here. Next part is we have to define that pin as output or input. As a Raspberry Pi send a signal on this LCD pin, on the DC motor pin, on the LED pin, buzzer pin. So all the pin work as a output pin. So to define that pin as output pin, we have to use this line GPIO.set mode, then setup, then pin name, then GPIO.out. So all the pin name I have defined one by one, and that pin work as a output pin. So that define as work as a output only. Now the next line is face mask training started code. So basically all whatever the line we will use now, it is basically used to train your code to detect the with or without mask data. So first line is again same CV2.cascade classifier. So you have to first delete this whatever the path in the code, and you have to provide the path from your file. So your file is this one. Right click on this file, copy the path, go to again program and paste here. Then after that your np.load. So next line is np.load. So whatever the with mask or without mask data you have collected before with correct phase data program, that data you have to load in a current file. So how to load? np.load function and pass the file path here again. So again you have to do the same path. Delete this whatever the path present here, and with mask. So again go to your folder, select this with mask, right click on this, copy the path, go to the file and save here, paste. Same for without mask, delete this, again go to your file, then without mask, right click, copy the path, go to program and paste here. So you can see we have given the with mask without mask.npy files, and that file will be loaded by using this function np.load in our current program. With mask and without mask, it is two variable to access that file. In current program, the program is file mask detection with hardware. So we have passes whatever the data we have taken, and we load here. Now the next line is we have to convert whatever the whatever the three-dimensional data into two-dimensional. Because you know that whatever the image we have taken, it is 3D dimension, but in our code we require 2-dimension data. So how to convert that 3 dimension to 2 dimension? With this line with mask. So whatever the with mask, this one, then dot reshape. So reshape is a function, then 100, we collect the 100 image, and the width is 50 into 50 into 3. So you know that in collect face we have given here face resize is 50 into 50. So 50 into 50 then into 3. So it is 3 is nothing but the RGB, that is a pixel value, and is pixel value having 3 variable RGB. So to convert that into 2 dimension, with mask we loaded this variable dot reshape, then 100, then 50 into 50 into 3, and with this we again here we got the 2 dimension data as a with mask. Same for the without mask, same line into 100, 50 into 50 into 3. So with this two line we get the two dimension data. After that, that two dimension data with mass or without mass, we have to combine that data into one variable. And how to combine that data? By using this line np dot r underscore with mass and without mass. So with this line we combine that data into one variable, and after that into that one variable we have to define we have to define the label for with mass and without mass. So let's say here first 100 and second 100. So you can see first 100 is with mass, and after that 100 it is without mass. So first 100 we have to give the 0 value, and after 100 we have to give the 1 value. So without mass data having the 1 value, and with mass having the data 0 value. So how to give that value? First what we do, we give 0 value to complete data. So np.0 x dot shape function with this 0, and we are passing here 0. So x dot shape, whatever the x here, all the data dot shape, that means giving the value to 0, and then label. Again after that label we are selecting after 100 value. So label, it is array of after 100 to end give one value. So here indirectly what we are giving, 0 to 100 to 0 and 100 to 200 to 1. So we are having a two label with mass is 0, without mass is 1. So here we are defining the label for that, and after that we have to train that whatever the label we have given, we have to train our algorithm. So how to train? So for training we have to split the whatever the value we have taken, we have to split that value. So let's say 0.40%. so out of 200, 0.40% value of data only train, and remaining that 60% data is used for actual programming. So to train, so to split that data to training data and actual learning data, we use this line train dot split x, that is our complete data, then label we have taken here, then test size is 0.40, is nothing but the 40%. So 40% data I am using to train my algorithm, and after that I am passing, I am using SVC type whatever say SVC type machine learning algorithm. For that I am creating svm variable, svm dot fit whatever the train data I have passed here, then prediction. So a prediction is nothing but like it is predicting how much it is correct. So in current case you can you can remove this hashtag, and from this hashtag you can see the score of prediction. So score of prediction should be less than 1. So if I run this code, so once I run this code, you can see the current prediction score is 1.0, and you can try with another value like 35 here, and again run the same code, copy this line or run the same code. So you can see with 35 again my prediction is 0.98, so is less than 1. So you can try an error and make sure that prediction should be less than 1, and whatever the value you are getting, save that value here. So once I get the less than 1, I have saved that value, and again I run the code. Sorry, so we got the prediction, so I again comment out this code. So this is my 0.35 value. You can use same value at your end. Now next line is name. Now next line is name is equal to 0. So it is basically dictionary, and dictionary having the two you can see dictionary having the two value. One value represent the key value. It is also known as the key value pair. So here you can see key is the 0 and 1, and the value is mass and no mass. So 0 key having the mass value, 1 key having the no mass value. So we will use name variable later. You can you will get to know what is the importance of this variable later. Now next line is font. So whatever the font we are using to display the on the square box, mass or without mass, that font we define, I have defined here. Now next part is you have to start the camera. To load the camera. To load the camera, I have already told you this line is used. Now next line is define all the LCD code. So I will not explain the LCD code here in this. So I will not explain the LCD program in this project, because till this program SPI also analog input void temperature, this program I have already explained in my LCD with temperature function LCD with temperature sensor simulation part. So please watch that video. So in that video you will get idea about each and every line. If I again explain that function here, it will take too many time, and main objective of this project is not work on the temperature or LCD part. It is meant to train the data and how to identify the data. So that is the main objective. So if you want to learn temperature sensor analog input, then this voltage, this temperature, and the LCD toggle and all LCD pin till line number welcome, then you can watch my LCD with temperature sensor data simulation video. I will provide the video link in the description. You can get the idea. Okay, so once you get the welcome message, from the on the LCD screen, now next part is we have to turn off all the devices by default. So to turn off all the devices, you have to send the zero signal on that devices. So how to send the zero signal on the devices? GPIO.output, then device pin name, then GPIO.low. So one by one I have turn off all the devices here. The next part is while one. So whatever the code inside that while one, it will execute infinite number of times. Next line is LCD dot. This line basically used to clear the LCD. Then we have to print the scan your face on the LCD. So it is basically this message will be printed on LCD by using this line. Then again capture dot read. So basically I already told you this line is basically used to open your camera and you will start capturing the image, live image. And flag, once the flag having one value, that is your camera is working perfectly. The flag having zero value, then camera will not work perfectly. Then if flag is 1, then go to here HAR cascade detect multiscale. So already told you detect multiscale is basically the algorithm which detect your faces and draw the square box on your face. And if the face is found, then draw the square box by using this line. Then after that square box you have to slice the square faces only. So how to slice? By using this line. So with this you will get face. Then again resize that face with 50-50 dimension, width and height. Then face dot resize, it is same. Then svm dot predict. So basically this is algorithm which is used to predict whatever the face currently I have with the learning algorithm. So if the svm dot predict having the one value, that means you are wearing the mask. So svm dot predict is equal to face, we are passing the face, and if it's having the zero value, and we already define here what is mean by zero value and what is mean by one value. So if it's having zero value, that means mask is detected, and if it's having one value, that means mask is not detected. So with this algorithm we are detecting the mask or not, and we are printing that value here. So if n is equal to 0, then it means the mask is detected. N is equal to 1, that means mask is not detected. Now next part is if once the face is detected, mask is detected, then we have to read the temperature. So how to read the temperature? Analog dot input function, and 0 is channel value of that temperature sensor, and with this 3 line we are getting the temperature into degrees Celsius, and we are printing the temperature on this window. Let's say if the temperature is less than 33, then it's okay temperature, then it's allowed. And next part is if n is equal to mask, that means mask is detected by this svm dot predict algorithm. N is equal to mask, and once the mask is detected, then we have to print the message get open on the LCD. So how to print that message? Again the same function, lcd.string get open on line number 1. Then we have to turn on the LED, because mass is detected, temperature is normal, then we have to turn on the LED. So how to turn on the LED? Just pass the high signal on that LED pin. And how to pass the high signal? GPIO.output LED pin, then GPIO.high. Then we have to turn off the red LED. So how to turn off red LED? Just pass the low signal, same with the same logic, GPIO.output red LED pin number GPIO.low. Then we have to open the gate. So how to open the gate? Pass 1 and 0 signal on the 2 different input pins of L29 3D IC. So to pass one signal on one pin, we have to use same logic, GPIO.output DC motor pin number 1 to low, GPIO.output DC motor pin number 2 to high. So it will open the gate for 0.3 second. Then after that it will close the gate after 0.3 second. Again reverse the logic, close the gate. Then we have to stop the motor at that point. And how to stop? Just pass the low signal. So in this way we turn on the motor, turn off the motor, and stop the motor. Now next part is temperature is okay, but mask, no mask is detected. So we have to print please wear the mask on the LCD. Then we have to turn on the red LED, turn on the buzzer. Then for some period, then turn off again the buzzer. So again same lines. You can see all the same lines are here. Now let's say if the temperature is less than 33 greater than 30 degrees Celsius, so no abnormal case, then high body temperature value you have to print on the LCD by using else law, else value, else function. And then we have to turn on the buzzer by using these two lines, and all other devices should be off. Expect red LED should be on here. So this is the code line. Then after that we have to open the camera, whatever the image on the screen, by using this cv2.image, and we have to print the mask detected or mask not detected message by using this cv2.putText message. Here you can see image we pass, then n, that is the value, then xy coordinate, then font, then color of that square box, and then the width of, and then our camera will be open here, and it is waiting for escape button. And once you press the escape button, program will be stopped. So this is the complete idea behind this project and the program. Now we will see how to run this project. So if you want to run this project, you can download my ready-made databases from my Google Drive link. So first file you have to download this face mask detection, then correct face, then Hertz cascade, then with mask and without mask. This is my train face file, and I have already told you how to create this file. If you want to create by your own, or if you want ready-made file, you can download this 4 file from my Google Drive link, and just go to this browser and click on run button. So you can see mask is not detected, so that buzzer start ringing. So in this way you can run your project. You can see temperature also here 30 to 31, and for that restart you can increase the temperature by your own in the code as I already told you. So in this way you can run your complete project.